Thank you. Okay, and then Jack, I think if you're ready, then we're ready to kick it off.
I'm totally ready. I'm totally excited. I want to thank everyone for joining this federal briefing focused on rapid response disaster research, NSF-supported networks and resources. For those of you who don't know me, my name is Jack Mazaris. I'm the Science and Technology Advisor for Natural Hazards, Disasters, and Resilience in the Division for Civil, Mechanical, and Manufacturing Innovation in the Engineering Directorate at NSF. In this role, I work across directorates at the Foundation and also coordinate with many of our federal partners. So it's a pleasure to welcome you today to help you better understand the incredible network of resources that we are building in the university communities in this space. This briefing, of course, was originally scheduled to be held at NSF and in person, but that plan, as so much else, has changed with COVID-19. But COVID-19 made everyone even more anxious to be able to move forward with the briefing, and CONVERGE is anxious to share their efforts with you. They've been organizing and catalyzing the academic research community in some really new and innovative ways. And they're also interested during the discussion section to learn more about your efforts as well as your questions. As you saw from the flyer, the CONVERGE Leadership Corps is going to present and then respond to questions and answers. And then when they're done, we have an additional hour for the federal family to stay online from 2 to 3 so that we can take this opportunity when we're together to do some of the coordinating that we want to do. So thank you again for being here. I'm going to turn this over to Lori Peek, who is a full professor in the Department of Sociology at the University of Colorado Boulder and also the director of the Natural Hazards Center. Lori is a powerhouse in making sure that the research communities in disaster research are well organized and motivated, and she herself has done disaster field research since after 9/11, Katrina, Deepwater Horizon, Sandy, and other disasters. She's well experienced and has a couple of award-winning books on post-disaster research. So with that, I'm going to turn you over to Laura.
Thank you so much, Jack, for that introduction, and thank you for welcoming everyone here today. So on behalf of the entire CONVERGE Leadership Corps, we wanted to welcome you as well. And please know that we're grateful for your time and attention. And we especially want to thank our NSF program directors for their support. As Jack noted, the members of the CONVERGE Leadership Corps will be with you from 1 to 2 p.m. Eastern today. We have prepared about a 45-minute presentation to offer a high-level overview of our various NSF-funded initiatives and our joint activities. We have reserved the last 20 minutes or so for questions, comments, and information sharing. If you have questions or comments that you want to share at any point during the presentation, please add those into the chat or the Q&A box. Jennifer Tobin has kindly agreed to moderate those inputs throughout the session. Please note that we are recording this first hour of the briefing. Then at 2 p.m. Eastern, those of us in the Leadership Corps will leave the Zoom call, and then from 2 to 3 p.m., Jack will facilitate an open discussion with NSF and federal partners. As we were preparing for this federal briefing, we identified the following 4 objectives for our presentation. First, we will introduce the structure of the CONVERGE Leadership Corps. Second, we will describe our mission and what we are working to achieve together. Third, you will hear from each of the principal investigators of the various components of the Leadership Corps, including the leaders of the Extreme Events Reconnaissance or Research, also known as the EER networks, as well as the principal investigators for the facilities that support natural hazards research for our nation. Fourth, and finally, as representatives of the academic hazards and disaster research community, we are looking forward to learning from you about how we can most effectively partner to share resources, information, and data in the context of natural hazards research. Established in 2019, the CONVERGE Leadership Corps brings together the principal investigators for 7 NSF-funded extreme events reconnaissance or research, again, the EER networks, as well as the leaders for 4 NSF-funded components through the Natural Hazards Engineering Research Infrastructure, also known as NEARI. You will hear from the principal investigators for each of these networks and facilities. We are all university-based researchers, but we also each have a history of collaborating with federal mission agencies in our hazards-focused work. We have learned a great deal along the way from other major natural hazards research coordination networks, such as the NOAA RESA program, NIST Disaster Failure Studies program, USGS's Strategic Sciences Group, NIH's DR2 program, and FEMA's mitigation assessment teams, among many others. We want to underscore at the outset that our leadership corps recognizes and honors that there are many other well-established networks in the natural hazards reconnaissance space. Our leadership corps, however, is dedicated to linking together the National Science Foundation supported EERs and the NSF NEARI components that facilitate and advance the work of the academic natural hazards research community. I know that the figure that I just showed you on the prior slide was a lot to take in, and we will be showing you plenty more acronyms before this is all through. So we wanted to pause to show you these pictures now to reorient to a simple fact. The establishment of the Leadership Corps means that for the first time, representatives of various academic communities in geotechnical engineering, structural engineering, social sciences, nearshore sciences, operations and systems engineering, and sustainable material management are all working together to promote cross-disciplinary and interdisciplinary research. We were at a meeting at NSF last fall when we could still come together for meetings, and one of our program directors was with us. We were hashing through a number of issues, getting caught up in the details, as we sometimes do, and she paused and said to us, "Don't forget the power of the fact that you are all in the same room together." That's it, exactly. For the first time, we now have an infrastructure to bring together the principal investigators for various disciplinary and interdisciplinary academic research communities in the hazards and disaster field. And if you want to know why Tim Cockerell is holding a tractor in that photo, you will have to ask during the Q&A. Our central mission as a leadership corps is to advance ethically grounded, scientifically rigorous, disciplinary and interdisciplinary academic extreme events research. What that means in practice is that we do several things, including identify and coordinate researchers, both within our respective disciplinary communities, but also across them. Both before and during this pandemic, we have mobilized to conduct virtual reconnaissance as well as field reconnaissance research. We offer education, training, and mentoring opportunities as we are attempting to cultivate a diverse next generation of researchers. One of our goals for our 5 years together is to write a rapid response research science plan to set a scientific agenda to collect a common data block across disaster events to allow for greater replication. And we are working, as you will hear today, through the RAPID facility and the Design Safe Cyber infrastructure to create a culture shift in our field towards systematically collecting, publishing, and sharing disaster data. To further the mission to identify, coordinate, and mobilize academic hazards and disaster researchers, the CONVERGE Leadership Corps brings together the 7 NSF-funded extreme events reconnaissance and research networks. The networks are dedicated to geotechnical engineering, social sciences, structural engineering, nearshore systems, operations and systems engineering, sustainable material management, and interdisciplinary science and engineering. You are now going to hear briefly from the leaders of each of the NSF EERs. We have organized this so you will hear first from the 4 EERs in our broader ecosystem that are predominantly dedicated to reconnaissance, or the rapid collection of perishable data during and immediately following disaster. Then you will hear from the 3 EERs that are dedicated to research across the disaster life cycle, including preparedness, response, recovery, and mitigation. We hope that if you are interested in learning more about a particular EER, you will pose a question in the chat box or follow up directly. With that, David Frost, over to you.
Well, good afternoon. I am the Elizabeth and Bill Higginbottom Professor of Civil Engineering at Georgia Tech and head up the Geosystems Engineering group there. More importantly, I am the PI and chair of the Geotechnical Extreme Events Reconnaissance Association. To provide a very short overview of that organization, it was formally established in 2006 with NSF funding and emerged out of a series of much more informal and perhaps not that well coordinated activities that were responding at the time predominantly to earthquakes. It has evolved since then to broaden into a full spectrum of hazards that involve geotechnical components. Our membership profile is one that includes a range of geoprofessionals as well as other scientists and engineers. The key thing is we're folks who are interested in geotechnical hazards. Our current membership is about 480, and that is split about 80% nationally and 20% internationally. And the importance of our international membership is that a number of our responses are and team deployments are for international events. And that's important because since we deal with, to some extent, a number of rare events, then being able to deploy teams that will study an event in another country, but that provides important lessons for us to bring back to the United States is particularly important. The primary hazards we look at are earthquakes, landslides, debris flows, floods, and essentially any other events with geotechnical consequences. And to give you an illustration of that breadth, we are in the process of deploying a small team to Western Nevada to gather data after the recent earthquake there. And at the same token, my email and phone have been busy this morning because we're also evaluating whether a response to the dam failures in Michigan is warranted. Some of our more major reconnaissance projects in the last year involved the Ridgecrest earthquake in California and the Hurricane Florence in South United States. We have conducted 55 national and international responses since 2006. Some of those have been relatively small teams, perhaps a 4 to 6 person team. Others have been multi-phase efforts that might have been involved as many as 25, 30, or even larger numbers of team members, again, driven by the scale of the event. The types of data that we focus on as an organization is what we call perishable data. And that is data that is gathered in the immediate aftermath of extreme events. There is much other important data that is collected in follow-on activities, but for the focus of GEAR, we really emphasize the importance of perishable data. And that is data that may be no longer available or disappear after some relatively short period of time after an event. A key element of our dissemination and communication is through our website, gearassociation.org, and also all of our post-disaster reports are published at that website. With that, let me hand over to Tracy Kajewski.
Great, thanks, David. I am Tracy Kajewski-Correa, a civil engineer by training and jointly appointed in the College of Engineering and the Keough School of Global Affairs at the University of Notre Dame. I also serve as the inaugural director for STEER, the Structural Extreme Events Reconnaissance Network. Now, STEER was founded in 2018 to mobilize teams of structural engineers as well as wind, coastal, and earthquake engineers under missions that document the performance of the built environment, including things like buildings and other civil infrastructure. We're looking at evaluating that performance under events such as windstorms, hurricanes, tornadoes, for example, earthquakes, and tsunamis. Now, STEER has adopted a 3-level response hierarchy that includes both virtual and field-based data collection modalities. Our products, which are briefings, reports, and curated data sets, are consumed by researchers, practitioners, and policymakers, including those in the areas affected by these disasters. Our responses to date have focused on impacted communities in both the United States as well as abroad. You will see 2 notable examples on this slide, Hurricanes Michael and Dorian. I understand that you will have access to these slides after our meeting today, so I invite you to click on the Dorian link on this slide to see an example of the data products that we produce and share immediately with those managing response and recovery activities in the Bahamas, in collaboration with our colleagues at the Rapid EF, who will speak later in this presentation. Now, one of the hallmarks of STEER is our ability to access these areas quickly and efficiently, and to assess damage to structures using mobile platforms. And then we enrich these mobile data assessments with data gathered from other rapid imaging techniques, such as some of the data types listed here. What is notable is that our damage assessments are accessible to the public in near real time through the link provided on this slide. And we have worked to also integrate our imagery into Google to further broaden its impact through the Street View platform. So I will now hand it over to Britt, and she'll tell you more about her organization.
Thank you, Tracy. I am the leader of the Nearshore Extreme Events Reconnaissance Association and am a senior scientist at Woods Hole Oceanographic Institution. NEAR was founded in September 2019, so just last year, so we're just getting started. And as Lori mentioned, and similar to GEAR and STEER, the goal of NEAR is to obtain perishable scientific, engineering, and socioeconomic data that's required to improve the understanding of storm processes. So our focus is somewhat narrower. It's on extreme coastal storms in which ocean processes and flooding impact U.S. coastal regions and communities. We currently have 74 members who span the disciplines of ocean, earth, atmospheric sciences, biology, engineering, and social scientists. And our goal is to work together to understand the interactions and feedbacks between processes within our respective disciplines, within the natural and built environments, and then also the human actions and reactions to those events. A key element of our association is a focus on obtaining pre-event observations and measurements of changes during events, which will be altered by the event and thus are perishable by definition, but also are needed as a foundation for later recovery-based studies of how the system might change after the event. In order to collect these pre-event observations, it's important to coordinate very rapidly. By having a national network of members, our hope is that we can coordinate with other groups and deploy rapidly for an impending event. We just were initiated last fall, so we haven't been through very many storm events yet. We did, however, do a dry run for Hurricane Dorian before we actually had funds to begin started, but we had 15 members who mentioned that they would have been available to respond if we had been a ongoing NEAR association at that point. And we currently have grown quite a bit, so we expect to have members available to be able to respond and to coordinate with other agencies to collect these observations. To learn more about NEAR, you can go to the link that's on the website here or on the slides, nearassociation.org. And I'm now going to hand this over to Jeong Choi, who is the leader of SAMIR. Thank you.
Thank you, Britt. Hello, everyone. I'm Juyong Choi. I'm an assistant professor of civil and environmental engineering at FAMU FSU College of Engineering. I am also the PI for SAMIR. Like the other ERs, SUMER aims to advance the hazard research, but with a focus on sustainable management of disaster debris by collecting and disseminating post-disaster data, as well as providing guidelines, tools, and training that are useful for interdisciplinary scholars who are interested in this subject. Our organization was founded in 2020, the last February. So we are still in the early development stage. Actually, our organization is building upon the workshop which was held in last year and supported by NSF, where we could identify lots of research questions and the data gap. So in order to address these challenges, these gaps, we plan to open our membership to interdisciplinary scholars, including the engineers, social scientists, and economists. So right now, our current membership, we only have 3, including me and the other 2 associate directors. But starting September, we plan to actively promote our organization to the broader communities. We are interested in all the different types of man-made and natural hazard events which cause debris and waste management challenges. And during the development stage, during the development of this organization, we plan to deploy the team to the disaster site as the pilot project, while we plan to respond to the extreme events through the virtual assessment. For example, right now, with the help of OSEEER, we are working on the preparation of the 2 virtual assessment reports for the recent Tennessee tornadoes, with a focus on the impact of the pandemic on debris operation. Data type, we plan to collect the pre and post-disaster data, which will help us to better understand the disaster operations and management. So thank you. Lori, over to you.
Thank you, and Young, we're so happy that you're now part of this network. Hi again, everyone. In addition to serving as the PI for CONVERGE, I'm also the principal investigator through an NSF-SupportEAGER grant for the Social Science Extreme Events Research, or OSEEER, network. Our OSEEER network was formed in part to respond to the need for more specific information about the status and expertise of the social science hazards and disaster research workforce. To that end, core to the mission of OSEEER is to identify and map social scientists involved in hazards and disaster research in order to highlight their expertise and connect social science researchers to one another, but also to the interdisciplinary teams that you've been hearing about today, as well as to communities at risk to and affected by disaster. Ultimately, the goal of OSEEER is to amplify the contributions of social scientists to advance the field through expanding the available social science evidence base and to enhance collective well-being. Back in August of 2018, OSEEER issued a call to our social and behavioral scientists, as well as to researchers in other allied disciplines concerned with the human consequences of disaster, to join OSEEER. To date, we have had over 1,100 social scientists globally sign up for the OSEEER network. We study a range of hazard types and have recently mobilized in response to the Puerto Rico earthquakes and also in the midst of the pandemic. OSEEER researchers have come together to form over 80 social science and public health working groups that are advancing convergence research. I'm going to pass this over to David Mendonca now.
Thanks, Lori. I'm David Mendonca. I'm an associate professor in industrial and systems engineering at Rensselaer Polytechnic Institute. OSEEER is really concerned with developing robust methods for prescriptive decisional guidance in this domain. That often includes critical infrastructure systems, logistics, and similar applications and domains. In terms of our thematic areas, I think one particular concern is with the development of methods that we need to explore and exploit historical data in order to assess the degree of robustness of the models that we develop. I think a real opportunity in this area is the growth of understanding the role of human agency and human autonomy within engineered systems. And that means the field is growing and expanding. And for that reason, we are seeking to attract early career researchers to this effort. A couple of the themes that are occupying us at the moment are really in intelligent human-machine systems, so dividing decision-making responsibility there, distributed versus centralized decision-making regimes, and importantly in multidisciplinary modeling and simulation. I should say that the other universities that are most deeply involved here are University of Michigan, and that is, the person there is Laura Albert, and then University of Wisconsin, and that is Seth Geikela. So again, thank you for coming and look forward to any questions.
Thank you, David. The 7th EER, ICEER, or the Interdisciplinary Science and Engineering Extreme Events Research Network, is dedicated to advancing interdisciplinary hazards and disaster research and the science of team science. To that end, ICEER, unlike the other networks, is not a membership-based organization, but instead ICEER is focused on providing the tools and knowledge to facilitate the sort of interdisciplinary and convergence-oriented research that we are trying to encourage through the leadership core. We have, for example, worked with members of the community through an NSF workshop grant to compile a series of journal articles in the journal Risk Analysis, focused on interdisciplinary methods and approaches in hazards and disaster research. And I really want to acknowledge David Mendonça for his vision to move that forward. We will also be following that special issue of Risk Analysis on interdisciplinary methods in the field with a first of its kind edited volume that will be published in the coming years. We've realized that that was a lot of EER information for all of you who are kindly sticking with us on this federal briefing. So please don't worry, there won't be a quiz at the end of this. Our goal here with this exercise and rapid fire information sharing was to give you a sense of the NSF funded research coordination networks that already exist. These EERs allow us to better coordinate both within our disciplinary communities, but also to reach across disciplinary boundaries. Now, we are going to shift gears just a little bit by reviewing the technologies, resources, and scientific and engineering infrastructure available through the NSF-supported Natural Hazards Engineering Research Infrastructure, or NEARI. So with that, I'm going to turn this over to Julio Ramirez, who serves as the principal investigator for the Network Coordination Office for NEARI. Julio, over to you.
Thank you, Lori, and greetings to everyone. I am Julio Ramirez, the Carl Kettlehutt Professor of Civil Engineering at Purdue University and Director of the Network Coordination Office of NEARI, the Natural Hazards Engineering Research Infrastructure. I am delighted to be here today and to contribute to the important efforts of CONVERGE and the EERs you just heard from. I've had the privilege of 10 years of association with research infrastructures sponsored by NSF. From 2009 to 2015, I led the George E. Brown Jr. Network for Earthquake Engineering Simulation, NEAST, for 10 years. NEAST, with its laboratories and cyber infrastructure, served tens of thousands of users around the world. Since 2015, NSF CMMI began establishing the next generation research infrastructure with a multi-hazard focus on earthquakes, windstorms, and associated hazards of tsunami and storm surge. NEARI supports research operations as a distributed multi-user national facility. NERI is comprised of separate research infrastructures awards for a network coordination office at Purdue University, cyber infrastructure at the University of Texas at Austin, Design Safe CI, a computational modeling and simulation center at the University of California, Berkeley, 8 experimental facilities, and CONVERGE. The NERI portfolio of experimental facilities consists of, as you see in the slide here, 2 wind research facilities at Florida, one at Florida International University and the other one at the University of Florida. A mobile geotechnical research laboratory at the University of Texas at Austin, a large scale structural real-time hybrid simulation laboratory at Lehigh University, a large multi-degree of freedom outdoor shake table facility at University of California, San Diego, and a large-scale tsunami and storm surge facility at OSU. And finally, a post-event reconnaissance facility, RAPID, at the University of Washington. May I have the next slide, please? The NCO team consists of Purdue University with partner institutions, the University of Texas at San Antonio, North Carolina State University, Texas Tech University, the U.S. Naval Research Laboratory, and the University of Hawaii at Manoa. The NCO serves as focal point for the research community and maintains a community-based NERI science plan with its latest edition appearing in January 2020, posted at the NERI Cyber Infrastructure Design Safe CI. The NCO manages scheduling of experimental facilities and coordinates all components to ensure effective and fair governance, efficient testing, and user support within a safe environment. The NCO also leads the NERI-wide educational and outreach activities, develops a strategic national and international partnerships, and coordinates NERI activities with the other awardee components. Now I look forward to your question, and it's my pleasure to turn the presentation over to Professor Joe Wortman, leader of the NERI Rapid Facility. Thank you.
Okay, thank you, Julio. As Julio mentioned, I'm Joe Wortman. I'm based at the University of Washington. I'm a professor of civil engineering. I'm also director of the Rapid Facility. Our mission is to provide investigators with the equipment, software, and support services needed to collect, to process, and to analyze perishable data from natural hazards and other extreme events. And our portfolio includes a vast range of instrumentation, including a suite of drones. Shown in the photo here is our flagship drone platform with a mounted LiDAR system. We have a hydrographic survey vessel that's portable, seismological arrays. We have a number of terrestrial LiDAR instruments, including some long-range instruments extending to 2.4 kilometers. We have mobile imaging or a street view system. We have portable EEGs, tools that can be used by social scientists. And we're also involved in the development of mobile software, including RAP, which is right now developed and optimized for an iPad, and we'll be releasing an iPhone version for that later this year. Since we became field operational in 2018, we've supported over 50 field missions worldwide in support of 30 plus organizations, including some of the federal agencies that are represented here today. Our community includes over 200 individuals from academia and from federal agencies who have been trained through some of our hands-on workshops. We go to the next slide. I want to show an example of just some of the data products that we have developed or helped users develop over the past couple of years. Shown to the left is a gear mission that we help support. That's Alex Grant, who's a research scientist at the USGS. And Alex has taken our long-range scanner and working in collaboration with a couple other members from the gear team, conducted long-range surveys that were then ultimately fused to make a digital city showing that this area in the immediate aftermath of the earthquake. And that's a survey that is captured at centimeter resolution, so showing some of the kind of power of these data products and what can be developed with the instruments. To the right is a large volume building survey that was an outgrowth of a STEER effort. And this included surveys at some DoD facilities. One of the things I want to mention about this is that a lot of the magic happens here, not just with the acquisition of the data, but it's the post-processing that allows us to do some techniques and tricks such as removing architectural aspects to just leave the structure exposed itself for post-disaster analysis. I'll go to the next slide, which highlights a current mission that we're involved in. This is the COVID-19 Seattle Street View campaign. We are deemed a critical facility by the University of Washington, and so we are still open and operating, although our staff is working from home largely. But this shows Jacqueline Peltier, one of our operations engineers, who's about to deploy on a Street View survey across Seattle. This is a survey that was developed across the broad spectrum of socioeconomic neighborhoods in Seattle, and this is a program that's going to be capturing Seattle in the current situation with the pandemic and hopefully during its recovery over the next year to year and a half. This also has an element of artificial intelligence for parsing and for organizing and automatically extracting information from these Street View data sets, and I've shown you an example of that below with pedestrian counts, car counts, and businesses being open and closed and so forth. With that, I'm going to pass it on to Ellen Rathje.
Great, thanks a lot, Joe. My name is Ellen Rathje. I'm a professor in civil engineering at the University of Texas, and I'm also the principal investigator for the Design Safe Cyber Infrastructure of NEARI. We've been around for about 5 years, since 2015, and our vision is to provide the data and cloud-based tools that researchers need to do transformative work in the areas of natural hazards engineering as well as just general natural hazards research. To strive towards that vision, we have multiple components that contribute as listed here. Importantly, we have our data repository, which is the Data Depot, which provides both informal data sharing among research teams as well as formal data publishing ultimately. We provide the cloud-based tools in the Discovery Workspace, and those tools have access to all the files that are in the Data Depot. Specifically for the EER community, we have the Reconnaissance portal, which facilitates the discoverability of the data, the important data that is collected and then ultimately published by the EER community. And then, of course, training the research community to use the cyber infrastructure. We have a wide range of tutorials in our Learning Center. To date, over the last 5 years, we currently have about 5,000 users. We serve 15 terabytes of public data. An additional 200 terabytes are private with research teams that may ultimately be published. We have provided 30,000 tool jobs using our Discovery Workspace tools, and we have over 100,000 views of our online training materials. And you can access all these components at our website, designsafe-ci.org. Can you take the next slide? Great. So a closer look at the components here in Design Safe that enable research. You see they're all labeled here in the research workbench. The Data Depot, which is where the formally published data ultimately reside. And what's important here is that we want to have archived data sets that are available for the long term, such that researchers not only today, but tomorrow can use these data in their research and not only use one single data set, but potentially integrate data sets from multiple organizations, multiple investigators. But importantly, we want these data to not only be well organized and available, but we want them to be citable. So each data set is provided a digital object identifier, DOI, which allows others to easily cite that data in their work. You can see some of the cloud-based tools that are available, the Poetry Data Viewer, which helps people view in the cloud some of those point cloud data sets that Joe just mentioned. We also have Jupyter Notebooks, which allow researchers, again, to access data in the cloud. And then finally, you see the Recon portal there with the map, which shows all of the natural hazard events for which we have data. And importantly, we're not only serving NSF researchers, we're available to the global community of researchers, as well as researchers that are funded in other parts of other federal agencies. So just an example, the NIST Center for Excellence just recently published some of their data via Design Safe. So we're trying to really broaden our exposure and access to data in natural hazards engineering. And with that, I will pass it over to Lori to finish things up.
Thank you, Ellen. So as Julio mentioned, CONVERGE is actually the most recent facility to join the NEARI network. We were established in 2018, and as you have already heard much about today, one of the central tasks of CONVERGE is to identify, connect, and coordinate researchers from various disciplinary communities. In addition to that, CONVERGE is also committed to encouraging the ethical conduct and enhancing the scientific rigor of research through offering many free resources such as online training modules, research check sheets, and research briefing sheets that are open to all. Following from the NSF 10 Big Ideas, CONVERGE also promotes convergence research, or research that is problem-focused, solutions-oriented, and deeply integrative. For example, recently, we put out a call for COVID-19 working groups, and we required that all of the groups have at least 3 disciplines represented in their membership. And these groups are already advancing a convergence research vision. CONVERGE is, as you have been hearing throughout this briefing, also responsible for bringing together the leadership core, and it has been a great honor to work with these talented and committed people you've heard from today. Now, to close us out, the leadership core wanted to share a few of our collective accomplishments with you. Please know each one of the EERs in the NEARI facilities has achieved an enormous amount on their own, and I hope that you will take the time to get to know each of the networks and the facilities that you've heard about today better, as they are all doing truly remarkable and transformative work. But what we wanted to focus on here is what is now possible for the academic community now that we are all together in the same room, either literally or sometimes figuratively. So I'm going to share 5 concrete examples of things that we have accomplished now that the leadership core has come together. First, we now meet regularly to advance our efforts, and this has allowed us to help teach one another and to share best practices. GEAR, for example, which is the longest standing EER, generously invited all the new kids on the EER block to their advisory committee meetings so that we could learn from their existing practices and then advance our own. Second, one of our first tasks as a leadership core was to write an internal communications plan so we can more effectively communicate with one another when major disasters are unfolding. That communication is made possible because of Design Safe and the Slack channels they've established for us, and then that helps us to better communicate and collaborate with all of you. Third, CONVERGE has created free online training modules on topics such as cultural competence and university IRBs, which the other EERs either recommend or require for their members. So we are doing more and more cross-training with our researchers. Fourth, through RAPID, we now have access to equipment that helps all of us to more systematically collect data. And fifth, Design Safe, CONVERGE, and RAPID joined forces to develop the first ever social science and interdisciplinary data model to ensure that engineering disciplines, but also other disciplines, would have access to the state-of-the-art cyber infrastructure offering through Design Safe. Now OSEEER, for example, is planning to utilize that resource as well to advance several of their methodological goals. We still have much to do together, including our plan to write a science plan for the academic rapid response research community. We are also meeting these next 2 days to discuss how we can help issue helpful guidance for natural hazards research during the pandemic. In closing, we want to emphasize how excited we are to be with you today, to share that now, for the first time, academic hazards-focused disciplinary and interdisciplinary communities are working together on a larger scale to advance research coordination, ethical best practices, scientific agenda setting, systematic data collection, data sharing, and publication. We are looking forward to learning more about what has landed from this presentation with you, what you're interested in learning more about, and of course, what you would like to share with us about what you are doing. I'm going to stop sharing the slides now so we can flip our videos back on and see one another. And then Jen is going to help us by moderating the Q&A. She can either read from the chat box, or if you want to raise your hand, Jen will call on you so that you can ask a question or make a comment or share information with us. Thank you again for listening to the presentation and for being with us today. And thank you, Wendy Walsh, for the emoji clapping hands.
Say, Laura. Well,
yes,
people are
Jack,
getting their thoughts together. I was wondering if you would say a little more about these working groups that have been convened around COVID, because I think it's a very exciting opportunity for our universities to become better coordinated.
Yes, thank you for kicking us off, Jack. So one of the things that CONVERGE does after a major disaster is that we've started holding something that we call virtual forums. And so we did this after the Ridgecrest earthquakes last July, and then after the Puerto Rico earthquake sequences, we held another virtual forum, and then we held 2 major virtual forums in response to the COVID-19 pandemic. And one thing that immediately became clear as hundreds of researchers logged on to these virtual forums was that A, there was already much research underway, and B, that there was a real desire to share that research with one another, and C, that there was an additional desire to figure out how we could partner better together. And so what we did through CONVERGE was put a call out for COVID-19 working groups. And again, the major requirement was that there had to be at least 3 or more disciplines represented in those working groups. And we ended up receiving well over 100 applications for COVID-19 working groups, representing well over 1,000 researchers across the social and behavioral sciences, but also including many other disciplines. And so in the end, we ended up funding about 80 COVID-19 working groups focused on methodological issues, various issues with population groups, organizations, the whole spectrum, because this pandemic has obviously left no aspect of our social world untouched. And so that's just one example of where, prior to the establishment of this CONVERGE Leadership Corps and these various research networks, we didn't have this sort of large-scale infrastructure in place to be able to reach out to the research community, but also to reach into their collective knowledge and wisdom. And already, I have to say, it has just been extraordinary to see what these working groups have done. They're self-organizing. The one on extreme events in a time of pandemic, an earthquake in a time of pandemic, they have over 60 members. They're meeting regularly. They use Google Docs to share with their research ideas. Another group has already submitted and received funding for an NSF Rapid. Other groups are coordinating not just across the US, but across international boundaries. And so that's just, again, one really specific example of how, now that we're all really organized in these networks, how we've been able to mobilize in the face of this global catastrophe. And now we have a framework to learn from and to improve on and to enhance as we move forward. So thank you, Jack, very much.
And Lori, I'm not seeing any questions or comments come up yet. Is there a directing comment or question that you have to start the conversation?
Very nice. Thank you, Jen. Robert, would you say, Robert, I guess, would you like to take it away with a question or comment?
I would. I thank you for putting this together. It's been very informative. you really should know, I can assure you, that there are a lot of kindred spirits at the USGS who are very interested in these extreme events, right? We do have a number of activities going on at the survey where we are looking at things like earthquakes and wildfire, certainly flooding, increasingly HABs, things of that nature. And what the question I want to ask is, I heard about a lot of those things, but I had a hard time figuring out who was dealing more with hydrology and with the floods or the low flows, and if there's a distinction there between amongst the 7 groups.
Britt or Tracy or David Frost, would one of you like to field that one?
I can start. I would love to have David and Tracy chip in. This is Britt Raubenheimer with the Nearshore extreme events. I think I've talked with you before, Robert, and have been in touch with many people in the USGS storms group, and our NEAR is coordinating with the storm group. We certainly are interested in flooding impacts, coastal ocean wave impacts. So we are very interested in the hydrology and how that hydrology interacts with and what the feedbacks are with structures, with social reactions and other geomorphology type things, the atmospheric, the interactions and feedbacks between processes during storms. So we are, I think there's overlap between all of these groups, and our hope during a extreme coastal storm would be to coordinate with GEAR and with STEER personnel, as well as with USGS and other agency personnel. And that's one of the things coming out of CONVERGE that is really exciting, is that ability to coordinate between groups and trying to improve that. Tracy or David?
If I may add a little to that, so maybe I didn't explicitly identify entities, but an important part of any of our responses is coordination in the field with other agencies, whether it's USGS, whether it's the Corps of Engineers, whether it's Federal Highway. There are many federal agencies who are obviously either owners or investigators of both man-made and natural infrastructure. And so a great strength we have found over the years is the collaboration with these other organizations. At a more specific level related to floods, one of the things, first of all, that we do is when we pick a team leader, we're going to pick somebody who is familiar with, an expert in that particular topic area, but more importantly, probably has very deep connections with individuals who may not be a GEAR member, but who are in some of these other agencies. And as an example, when we responded to the floods in Colorado, gosh, now that's about 4 years ago, our team leader was Jeff Keaton, who was an engineering geologist. And I know that Jeff worked very, very closely with various agencies. And in fact, I would go as far as to say that the end report that was produced by GEAR, and which included non-GEAR members as co-authors or whatever, was far better because of some of the work and inputs coming from agencies such as USGS and so on. So that's very much front and central to what we do.
Tracy, unless you have something else to add, there is another question, but did you want to say something else about Mark's question?
Yeah, no, STEER doesn't do flood response, so I will pass. Thanks.
Okay. Mark Leviton has a question about recon research activities before and during the hazard event. Mark, would you like to jump on and ask your question?
Collaborative disaster research. And
Mark, can you start over? Can you start your question over, please?
Oh, sure. Okay. I just wanted to thank you and congratulate you, Lori, and the whole team on this significant advance and how we infrastructure for doing collaborative disaster and hazard research. Specifically, it seems to me, I mean, that much, if not most, of the activities are focused on sort of post-disaster, post-event activities. But I did hear, particularly from Britt, for the NEAR, that they also had some focus on before and during. And I'd like to hear a little bit more about the capabilities from NEAR and for the other research or recon networks about what they either do or might plan to do in the future to understand and gather data or do research before and during the event. You know, of course, my focus is windstorms, and you know, we have this big challenge in windstorms. We've done a lot of disaster reconnaissance after the fact, but if we don't know what the hazard was, if we don't know what the winds were, if we don't know what the storm surge and those levels were, it's really, you know, we're missing half of the picture, as opposed to, say, seismic, where we get a lot of we have this great network of sensors around the world, and we get a real good information on seismic events immediately after they happen in terms of the hazards. So I'd like to hear, you know, what are some of the things being thought of before and during the event?
So Mark, you're a man after my heart too. I would like to preface this with GEER and STEER do also some pre-event deployments, especially for coastal storms where there is knowledge of the approach of the storm beforehand. But it is definitely a focus of NEAR to try and get out there before, because the perishable observations in our case often are the things that are going to be wiped out or altered during the event. So one of our major goals is to get pre-event observation, site characterization, and we are trying to coordinate with the USGS Storms Group because they do a lot of pre-event, having mounts for instruments already out there. But because of our interest in interdisciplinary interactions and feedbacks, we have biologists who are doing HAB type work, as Robert mentioned. We are in training, hopefully, other wind scientists. For Dorian, we were on the Slack channel trying to coordinate with people who were doing wind measurements during Hurricane Dorian on the US coast. And hopefully we'll continue to do that, possibly through some of the NIST collaborations as well. So that's, I mean, a goal of ours is to get out there, and our perspective is that by having this network of enough people, there will be people available who can respond rapidly. As I said, we haven't deployed yet because we are just newly formed, but we did have 15 members crossing many disciplines who said they would have been able to deploy rapidly for Hurricane Dorian. We would have been in contact with wind engineers who were deploying, would have been in contact with other individual researchers, Andrew Kennedy, many others who were making observations, as well as with the USGS Storms Group. And hopefully working together, that also will help us as far as access to sites, determining, you know, sharing information about where the impacts appear to be largest. There are going to be misses because we're going to deploy when we can't actually get out in front of the storm or the storm changes track like Dorian did. But working together, I think we'll be able to cover a lot of those misses.
Mm-hmm. And I know we're getting very close to the end of our time. And so one thing to Mark, that was a wonderful question, and just really wanting to emphasize that the NEARI facilities, almost all of the facilities that Julio addressed in his presentation, they really are focused on natural hazards mitigation. And so exactly that sort of pre-event work that you're referring to, and then several of the EERs recognizing that interconnection between the pre-event circumstances and then what unfolds in the actual disaster event. And so really appreciating the question so we can make sure and sort of make that whole life cycle more clear as we articulate the various things that we're doing through the EERs and the facilities. So thank you for that. And then Wendy Walsh, thank you so much for the comment that you put up in the chat box. For those of you who are on the phone who may not see that, Wendy directs FEMA's higher ed program, and she shared a Corona best practices page that they have through FEMA's website, and also was asking about the CONVERGE training modules and making sure they're used in classrooms and so forth. And that's something that we're working on right now. And so thank you for that, Wendy. And thank you again to all of you for joining this briefing today. We ask that you please stay on the line, because the leadership core members, again, we're going to leave this briefing so that then there can be time for the NSF and the federal partners to meet together, and Jack is going to facilitate that conversation. But again, please know that you can reach out to any of us, and thank you for listening to the briefing today and for the work that you are all doing in the natural hazard space. So thank you. And Jack, with that, we're gonna I'm gonna stop the recording. My dog is barking, so I'm going to stop the recording right now, and then I'm going to leave this running because we set this up through the CONVERGE Zoom account, but I'm going to leave the room so I'm not listening to anything, and we'll just bid adieu to everybody. So thank you again very much.
Thank you all. Thank you, Julio, David, Britt, Tracy.
Thank you, everybody, for listening today.
Thanks.
Thank you.
Thank you. Thanks, Jack.